Hello, I'm Sunil Divekar. Let's take a look at planar density. Planar density is actually a ratio of number of atoms centered on a plane divided by the area of the plane. When we talk about the cubic system, the simple cubic structure, the body-centered cubic structure and a face-centered cubic structure shown here. In simple cubic structure, we have atoms at the corners of a cube, and in this particular case the 100 plane is the one which is intercepting the x-axis and is parallel to the y and z axis. So this is for the simple cubic structure. Since I have marked x on this side, for all these are the 100 planes for the three systems. So these are the 100 planes. Now, if we were to consider the 100 planes for a unit cell, one would realize that in a unit cell we have a square of side A by A, and surrounding that unit cell would be squares also of side A and A. So in this case, if we focus on this particular unit cell plane, which is 100 plane, the atoms that are centered at the corners, for example, the top right is actually shared by square 1, 2, 3 of interest and 4. So it is shared by 4, and therefore we have, for a unit cell, only 1/4 of this atom that is available for that particular unit cell. When we talk about the number of atoms centered on a plane, therefore, you will find that there are 1, 2, 3, 4 atoms that are centered, and each of them contributes to 1/4 of the atom. Hence, the number of atoms centered is equal to 4 by 4, that is 1. And in this case, therefore, the planar density of 100 plane in a simple cubic structure will be 1 upon A square. A square is the area. Now, since the the lattice parameter A and the radius of the atom are related, as A is equal to 2r for a simple cubic structure, this becomes 1 upon 2r bracket squared, and that makes it 1 upon 4r square per whatever the units. It can be nanometer square. In a similar manner, when we talk about a body-centered structure, in a body-centered structure, the number of atoms are again 4 at the surface. The one at the body center is not on the surface and therefore not included. So this will be actually again 4 upon 4, that is equal to 1. And the planar density in terms of the lattice parameter A is still going to be 1 upon A square. The difference in this case is, for a body-centered structure, since the lattice parameter A is related to the radius by this relation 4r by root 3, this further tends to become 1 upon into bracket 4r by root 3 bracket square, and therefore the planar density at 100 plane for BCC structure is 3 upon 16r square. Moving to face-centered cubic structure, we note that the lattice parameter for the face-centered cubic structure is A is equal to 2 root 2r. The number of atoms, if we are to calculate, we find that we have 4 at the corners, shared by 4 unit cells, so 1/4 from each corner. But the one which is at the center of the face, if you cross the face with 2 diagonals, the center of the face is totally dedicated to this particular unit cell, and therefore we have 4/4 plus 1, and that is 2 atoms. So the planar density in this case for the 100 plane of FCC is again 2 by a square, and when you substitute this value of a, we have 2 upon 2 root 2 r, the bracket squared, and therefore the planar density at 100 plane for FCC is going to be 1 upon 4 r square per, of course, the units, depending upon the units. Let's say if nanometer is the unit, per nanometer square. So this is how you find a 100 planar densities for simple cubic structure, body centered cubic structure, and face centered cubic structure. Thank you.